Hi, you all are so welcomed here to the second section, Problem Solving with Asynchronous Programming. This is the first video of this section, Understanding Responsiveness. So let me give you a very quick recap of the last section we had, which was kind of introductory section in which first we have discussed the course overview and highlighted the overall topics that we are going to cover throughout this course. And afterwards, we have seen a real-world example to understand the concept of asynchronous programming in general to get a kickstart. As the name says, that this section is all about the problems that asynchronous programming tends to solve. So before we dive into the details of asynchronous programming, it is important that you are taught the basics of several concepts and the problems that arise in multitasking environments. One of such problems is the problem of frozen UI that arises when your application is no longer responding to the user action. Starting on the same track, responsiveness in the application is the one thing that you will stumble upon every time, even if you are an advanced software engineer. The problem mainly arises in the single-threaded applications. The issue is that the single thread available gets busy with other operations to be executed and taken care of. That thread is also responsible for updating the interface and handling user interactions, such as state changes from active to focus to hover, etc. These operations range from simple tasks to long-running I/O operations, such as network download operations or huge buffer of data to be stored on the file systems. Not only these, but long-running CPU-bound loops can also cause a delay in the threads and cause this effect. This leads to a frozen UI problem, where an app, however, is running, though it seems as the app is not responding or is hung. The responsiveness of the application ensures that your user do not face the frozen UI problem. That is, our app provides updates to the user in the form of a status or label on the desktop window. This enables the app to be more interactive and the user can interact with the controls on the screen such as buttons or input fields. In the same flow, we can provide the information about the background processes if there are any running. By following this approach, your users enjoy the app due to the fact that they know what the app is doing and the app is accepting any further commands they are issuing. This includes any command that is needed to terminate the background task, and it has a good approach and is less irritating and annoying for the user. Let's consider a very quick example to draw a clear image of what we have just discussed about the responsiveness of the application. You have an app, either mobile, desktop or web, to order a pizza. The app interface is quite simple and clean. You can see two drop-downs for the flavor and quantity and a button to place the order. You fill the required fields and click the order button. What happens in the background is your main thread gets busy to entertain this request. And as its results, the UI becomes stuck, frozen, that means unresponsive. What if you want to change the quantity of the pizza, but the GUI isn't functional? Until your first order gets executed completely, this will happen when your main thread gets free to take more inputs from the end user. See how much cumbersome and inefficient the whole process would be when we won't be taking care of responsiveness using some ways. Thus, the responsiveness of your application can increase the ability of your application to interact with the user and provide them with the live information about the background processes, tasks, and operations. You also enable the users to take more control over the processes of the application. This provides a trustworthy relation with the user as they know what your application is doing and why so. Moreover, you can let them control how these processes execute and even cancel or defer them.